Alright, so we are starting with Java, and here I should really change. Alright, so the, sometimes we will be iterating over multidimensional arrays. The enhanced version for the 4 also works on multidimensional arrays. Remember, however, that in Java, multidimensional array consists of pages of arrays. For example, a two-dimensional array is an array of one dimension. Array of one-dimensional arrays. This is important when creating over a multi-dimensional array because each iteration obtains the next array, not an individual element. Okay, right. Furthermore, the iteration variable in the for loop must be compatible with the type of array being obtained. For example, in the case of a two-dimensional array, the iteration variable must be a reference to a one-dimensional array. In general, when using the for to iterate over an array of n dimensions, the object obtained will be arrays of n minus one dimensions. To understand the implication of this, consider the following program. It uses nested for loops to obtain the elements of two-dimensional array in row order from first to last. So first we give the arrays some values and use for each. Okay. So from nums we have this. This is for each three. Three Java. So we go for each style for on a 2D array. So we have class for each three. Then we sum, and then I create an array. Then we give nums some value. 0 minus 3 plus for I equals 0 z equals 0 z equals 5 plus I can go nums of I j equals I plus 1 times j plus. Then we use the for each for to display the sum and the value. To display and sum the value. To display sum the value. So first we are obtaining an array from nums, an integer array, and then within that, and then we are extracting each of the individual integer from that array. Dot ranks value is maybe I can make it a little better. Print plus this, then we can add a new line here. And I also have to update the sum. Sum, and then finally we print out the sum. Summation sum. Okay, Java. Forgot this. Summation is 90. Okay. Then we want to notice how x is declared. It is a reference. It is a reference to a one-dimensional array of integers. This is necessary because each iteration of the for obtains the next array in nums, beginning with the array specified by num0. The inner loop then cycles through each of these arrays, displaying the values for each element. Applying the enhanced for. Since the for each style for can only cycle through an array sequentially from start to finish, you might think that its use is limited. But this is not true. A large number of algorithms require exactly this mechanism. One of the most common is searching. For example, the following program uses a for loop to search an unsorted array for a value. Simple search. Okay. The for each style for is an excellent choice in this application because searching an unsorted array involves examining each element in sequence. Of course, if the array was sorted, a binary search could be used, which would require a different style. Other types of application that benefit from each style for each style include computing an average, finding the minimum or maximum of the set, and looking for duplicates, and so average, finding minimum or maximum set on looking for duplicates. Although we have been using arrays in the example in this chapter, the for each style for loop is especially useful when operating on collections defined by the collections framework, which is described in the topic. More generally, the for can cycle through elements of a collection of objects as long as the collection satisfies a certain set of constraints. Then we have local variable type inference in a for loop. As explained in chapter 3, JDK 10 introduced a feature called local variable type inference, which allows the type of a variable to be inferred from the type of its initializer. To use local variable type inference, the type of the variable is specified as var, and the variable must be initialized. Local variable type inference can be used in a for loop when declaring and initializing the control loop variable inside a traditional for loop. When specifying the iteration variable in a for each loop. The following program shows an example of each case. Okay. right. So I can do that. Oh, okay, let's do that. So type inference in type inference in a form. Type inference for first use type inference with a loop control variable. Type with the controlled variable. So then I have the value of x. Then we go x equals 2.5. So x should be x equals x times 2. Then we print the value of x. Then we add a new line for padding. Okay, again, we use type inference with the iteration variable. With the iteration variable. For the iteration variable, we define an nonce by 6. Then we go then we print the values in nums array. Values in nums array. So we have b will be an integer. Okay. X is double. Here b is an integer. We add a new line for padding. Okay, let's see this. Right. There we go. Okay, so then we have the output is shown here. In this example, loop control variable x in the line is inferred to be type double because that is the type of its initializer. Iteration variable v in this line is inferred to be type int because that is the element type of the arrays now. One last point, because many readers will be working in environments that predate JDK10, local type inference will not be used by most of the for loops in the remainder of this edition of this book. You should, of course, consider it for new code that you write. Nested loops. Like all other programming languages, Java allows loops to be nested. That is, one loop may be inside another. For example, here's a program that nests loop. Okay, it's jump statements, then we move on to jump statements. Tree, put up tree, jump statements. Alright, Java supports three jump statements: break, continue, and return. These statements transfer control to another part of the program. Note, in addition to the jump statement discussed here, Java supports one other way that you can change your program's flow of execution through exception handling. Exception handling provides a structured method by which runtime errors can be trapped and handled by a program. It is supported by the keywords catch, throw, finally. In essence, the exception handling mechanism allows a program to perform a non-local branch. This exception handling is the last topic is discussed in its own chapter. Using break. In Java, the break statement has three uses. First, as we have seen, it terminates a statement sequence in a switch state. Second, it can be used to exit a loop. Third, it can be used as a civilized form of goto. The last two uses are explained here. Goto. So we're using a break to exit a loop. By using break, you can force immediate termination of a loop by passing the conditional expression and remaining code in the body of the loop. When a break statement is encountered inside a loop, the loop is terminated and the program control resumes at the next statement following the loop. So here's an example. We have a loop from I0 to 99, and if I becomes I is equal to 10, then we break the loop. As you can see, although the for loop is designed to run from 0 to 99, the break statement causes it to terminate early when I equals 10. The break statement can be used with any of Java's loop, including intentionally infinite loops. For example, here is a preceding program coded by use of a while. The output remains the same. Okay. We have when used inside a nested loop, the break statement will only break out of the innermost loop. Right, that is important. When used inside a nested loop, the break statement will only break out of the innermost loop. So as you can see, the breaks should be off in the inner loop, but the breaks in the outer loop doesn't. So as you can see, the break statement in the inner loop only causes termination of the loop of that loop. The outer loop is unaffected. Here are two other points to remember about break. First, more than one break statement may appear in a loop. However, be careful, too many break statements have tendency to destructure your code. Second, the break statement that terminates a switch statement affects only the switch statement and not any enclosing loop. Don't use too many break statements. If a break statement is within a switch, then it will only break out of that switch. Remember, break was not designed to provide the normal means by which a loop is terminated. The loop's conditional expression serves this purpose. The break statement should be used to cancel a loop only when some sort of special situation occurs, using break as a form of code. In addition to its use with switch statements and loops, break statement can also be employed by itself to provide a civilized form of go-to statement. Java does not have a statement. Java does not have a go-to statement because it provides a way to branch in an arbitrary and unstructured manner. This usually makes go-to written code hard to understand and hard to maintain. It also prohibits certain compiler optimizations. There are, however, a few cases where the go-to is a valuable and legitimate construct for flow control. For example, the go-to can be useful when you are exiting from a deeply nested set of rules. To handle such situations, Java defines an expandable form of break statement. By using this form of break, you can, for example, break out of one or more blocks of code. These blocks need not be part of a loop or a switch. They can be any block. And further, you can specify precisely where execution will resume. Ah, so we are using break as a form of go-to. This is interesting. Statements will resume. These blocks need not be part of a loop or switch. They can be any block. Further, you can specify precisely where the execution will resume. Because this form of break works with a label. As you can see, break gives you the benefits of a code without its problems. So the general form of the labeled break statement is break, then label. Most often, label is the name of a label that identifies a block of code. This can be standalone. This can be a standalone block of code, or it can also be a block that is the target of another statement. When this form of break executes, control is transferred out of the named block. The labeled block must enclose the break statement. The labeled block must enclose the break statement, but it does not need to be immediately enclosing. Most often, label is the name of the label that identifies a block of code. This can be standalone block of code, but it can also be a block that is the target of another statement. When this move break executes, control is transferred out of the named block. The labeled block must enclose the break statement, but it does not need to be immediately enclosing block. This means, for example, that you can use a labeled break statement to exit from a set of nested blocks. Right? But you cannot use break to transfer control out of a block that does not include the break statement. Okay, but you cannot use break statement to transfer control out of a block that does not include the break statement. Okay. So to name a block, put a label at the start of it. A label is any valid Java identifier followed by colon. Once, once you have labeled a block, you can then use this label as a target for a break statement. Okay. Doing so causes execution to resume at the end of the labeled block. For example, the following program shows three nested blocks, each with its own label. Break statement causes execution to jump forward past the end of the block labeled second. See. Okay, so we jump past the block that it labels. So running waits before the break. It says break second, this won't execute, then this won't execute, and this is after the second block, that is the third block. Okay. So all the blocks have to be named, right? This means so the label block must include the break statement, but it does not need to be immediately including. This means, for example, you can label break statement to a set of message blocks, but you cannot use break to transfer control out of a block that does not include the break statement. So we have breaks. Break means create a using break as a civilized then we start the boolean key true. Then we define blocks. These are tables. Then third. Then just have a print system that after print line. So before the break, if G break and then we give the label name. But it will continue break out of second row. Okay. So it will break out of second. So it must enclose, right? We can break out of first, we can break out of second. So we are breaking out of second. So after second, if I break out of third, then it will be well. It is the normal flow of execution. Break out of second. Break out of second blocks. Then some set this won't execute and neither will this executes. Finally, we move out of second and this is this is after second row. So this is after break execution will continue here. Okay. There we go. Okay. So one of the most common uses for a labeled break statement is to exit from a nested loop. Nested loop. Okay, so we can directly exit out of a nested loop. Okay, so it must contain the label must contain the break statement from which we want to break out of. Okay, now I get it. Taking function. Okay, break out of. This is the inner loop. Okay, as you can see, when the inner loop breaks to the outer loop, both loops have been terminated. Notice that this example labels the for statement, which is a block of code as its target. This is important that We can directly label statements as well. Keep in mind that you cannot break to any label which is not defined for an enclosing block. So you cannot break. For example, this program is invalid. We have one defined here. You see break. So if the loop labeled 1 does not include the break statement, it is not possible to transfer control out of that block. So write one more. Is jump this. You are breaking out of using break to exit the statement. Let's take void name string words. So I have a outer loop. Breaks out of the outer breaks of the outer label block slash statement. Right? So basically exiting both of the loops. And then we finally add a new line for padding. Loop completes. Loop complete. So let's see this. Loop. Then I have using continue. Sometimes it is useful to force an early iteration of a loop. That is, you might want to continue running the loop but stop processing the remainder of the code exporting for this particular iteration. Um, this is, in effect, a goto statement just past the body of the loop to the loop's end. The continue statement performs such an action. This is in effect a goto statement just past the body of the loop to the loop's end. In do-while loops, a continue statement causes control to be transferred directly to the conditional expression that controls the loop. So continue goes directly the checks the condition. In a for loop, the control goes first to the iteration portion of the for statement and then to the conditional. Okay, so it iterates first and then checks the condition. For all three loops, any intermediate code is bypassed. And here's an example that uses continue to cause two numbers to be printed on each line. So we have system with this and this. Okay, clever. Okay, this code uses the modulus operator. Alright, so I have the demonstrates continue. Let's write this function. Continue with Java. So we go here, say we have 0, we print 0, then we check do we right. Okay, is 1 is 0 mod 2 0? Yes. In 0 mod 2 0? Yes. Then we continue to the loop. We continue to the top of the loop, right? Then we iterate it again, then this time first it iterates, then we check the condition. So now this time it is 1, it prints 1. Then check is 1 this 0, no, then we print a new line. And so it goes. There we go. So the code uses the modulus operator. It checks if I is even. If it is, the loop continues without printing a new line. Okay, then we have, as with the break statement, continue may specify a label to describe which enclosing loop to continue. Okay, here's an example program that uses continue to print a triangular multiplication table 0 to 9. We have continue label, we define a label for loop. Then j equals 0. If j becomes greater than I, then we continue to the outer loop. Okay. Interesting. Let's write it in Java using continue with a label. Continue label. We define then plus, then we define an inner loop for each colors. So now better. You say equals 0, j less than 10, j is plus. So if j is greater than I, then we continue to outer, right? Else we simply print, then we have plus we print a new line. Else we simply print the table. Finally, print a new string. So there we go. Right. So then the continuous statement in this example terminates the loop counting j and continues with the next iteration of the loop counting I. So good uses of continue are rare. One reason is that Java provides a rich set of loop statements which fit most applications. However, for those special circumstances in which early iteration is needed, the continuous statement provides a structured way to accomplish it. Return. The last control statement is return. The return statement is used explicitly to return from a method. That is, it causes program control to transfer back to the caller of the method. As such, it is categorized as a jump statement, although a full description of return must wait until methods are discussed in chapter 6. At any time in a method, the return statement can be used to cause execution. Execution. The return statement can be used to cause execution to branch back to the caller method. Thus, return statement immediately terminates the method in which it is executed. Right. So we have an example where return causes execution to return to the Java runtime system since it is a runtime system that calls main. So we only get before the, as you can see, the final print line statement is not executed. As soon as return is executed, control passes back to the caller. One last point in the preceding program, if if statement is necessary. Without it, the Java compiler would flag an unreachable code. Because the compiler would know that the last print line would never be executed. To prevent this error, if statement is used, we detect the compiler for the sake of demonstration. So I can also So now I define again d equals to, let me print the message before return. Then I go if t done, this won't execute. So we have structured our early return. Yeah. So then we can finally move on to new chapter 6, introducing class 6. So that's it for today.